All right, so we're gonna just pick up where we left off last class. So we're working through the first lecture set. We left off talking about effectively just the sort of fundamental or key definitions in our study of sampling. And at the time that we concluded last lecture, we were actually breaking down this diagram on slide 8. And we were talking about some of the components within this diagram and sort of starting to realize what can go wrong with our sampling protocols after we have identified the target population and we have set up our sampling frame. Now, as a reminder, the target population is effectively just the collection of all elements or observations that we want to make a statement about. The sampling frame is okay, and we're back. That was weird. Sorry, one sec. All right. Sorry, can you guys still hear and see me? That's the first time I've ever had Zoom cut out in all the time I've been using it. It's no time like the present, I guess. All right, well, hopefully this doesn't happen again. We're still recording, so I guess it'll just sort of cut out. All right, so the target population is the collection of all elements that we want to make a statement about. The sampling frame is effectively just the list that we are using to contact all of these elements in the population. So in very simple examples, a sampling frame might be something like an email list, or it might be something like a list of names on a Facebook page, or on like the Discord server for the Math and Stats Club. So if that was your target population, then all of the person's names that have signed up for the server could be considered your sampling frame. Now, those obviously would be very small target populations, and in those particular examples, we probably wouldn't really need to employ a sampling strategy because we would be able to contact everyone. But for illustrative purposes, that's the idea. The frame is basically just your phone book. I don't know if you guys know what a phone book is, but your phone book for contacting everyone. All right, so the structure of the frame compared to the target population. So our target population here is this rectangle that sits kind of in the background of the photo, and then sort of in the foreground of the photo or the image, you have the sampling frame. The sampling frame is also sort of a rectangular shape that has these curved edges. Okay, what we can see from our study of the sampling frame is it's actually composed of, let's say, five different categories. So we have those people that are not eligible for the survey. So you can see that that particular category of the sampling frame sits outside of the target population. So there's no overlap between that component of the sampling frame and the target population. And then inside the target population, you have the actual sample that could be contacted for the study. And first off, what we'll notice when we look at the structure of the sample is that it only actually covers a subset of the population. So this part of the frame that I've outlined in red here, maybe I can just bold this a little bit more for illustration. So this part of the frame, which is highlighted now, it itself only covers a subset of the population. So there's already information that we aren't able to get from the target population based off of the particular frame that we might be using. Now, as a result of that, what we can see is, since the sampling frame only covers a subset of target population, we can expect there to be, it's a weird sentence, we can expect there to be sampling error, right? And the idea of sampling error is also something that you've likely heard of before in Stat 151 and Stat 252, for example, because we talk about these concepts very well. In Stat 151, we kind of just mention what it is. In Stat 252, we go into a little more detail. But the point is that this is an unavoidable error. You can see from the diagram itself that we're only even able to contact or potentially contact a subset of that target population. So inherently, there's going to be some error attached to the estimates that we are eventually going to calculate. Now, from that sample, what you end up with is a portion of the population that you're actually able to contact and get information from. So that would be our sampled population, which was initially this part that was outlined in green. And then I'll just kind of highlight over here to emphasize that particular structure. All right. And then we have other components. So for example, not reachable, refuse to respond, not capable of responding, that also make up a portion of the sample that we were able to reach, but they weren't able to give us any useful information. Now, in general, we can observe situations where we might have one or a combination of these different elements. So from the sampling frame, we might in other studies end up with the portion inside the highlighted green box, the sampled population, and that makes up all of the frame that aligns with the target population. So that would be a very good situation where we contact everyone in the frame and we are able to get useful information. That would be ideal. But we could also have maybe a sampled population and then a portion that are not reachable. So a portion that do not respond, for example. Or we could have a sampled population and a portion that refuse to respond. So any of the combinations are possible. I mean, technically, depending on the size of the study, and hopefully this doesn't occur, you could have a sample where you only end up with not reachable and refuse to respond and not capable of responding. So there is no useful information that comes out of that study at all. Now, again, the hope would be that this isn't something that we encounter, but it is a possibility. All right, so what we're going to start to get into now are a few definitions where we define some of these different elements in the context of the diagram and the key definitions. And then we're going to start to look at some examples that would help us to understand why studying different sampling protocols, and more importantly, help us understand, well, I shouldn't say more importantly, but we're going to look at a few examples to illustrate why understanding how to sample is important. So some motivating illustrations. Okay, our first exercise to demonstrate the key definitions, we have here scientific journals rely on peer review to assess the quality of incoming work. So the idea here is when you when you are aiming to publish some type of research, you send it to a group of experts, and those experts who are randomly selected themselves, usually, decide if the work is worth being published in a particular paper. So that's the process of peer review. So for every submitted, in this illustration, for every submitted paper, 3 reviewers are selected. This is actually usually the goal with most papers or journals that I have submitted work to, but sometimes you only end up with 2 reviewers actually giving any meaningful contribution. A lot of the time it's hard to find 3 reviewers, especially if the area is very small and there aren't a lot of experts in that particular field. So for every submitted paper, 3 reviewers are selected. Describe the element, the population, the sampling units, and the frame, and then comment on the structure of the frame. Okay, so in this particular illustration, we will define the element in this case as being the reviewer. Okay, so what we're focusing on here is the selection of the reviewer to assess the work. So the element in this particular case is the actual reviewer of the paper. Okay, so the target population in this case would be all area experts that would, well, area experts would actually be the best way to describe it, but we'll say, just to make it very clear, that is researchers who also work on the topic described in the submitted paper. If you wanted to be very brief about it, you could just say the collection of reviewers, right? All possible reviewers, but the reviewers are themselves researchers, so they would be area experts. Okay, the next thing we'll talk about are the sampling units. So as a reminder, the sampling units, if we look back at our key definitions, so the unit itself can be a collection of elements or an individual element. So in this particular illustration, the sampling units could just be the reviewer or the area expert themselves. That would be a very realistic interpretation. A lot of the time when I'm contacted to review a paper, I'm contacted directly by the editor. So I suppose in that sense, I would be the sampling unit. So it could be one of two things. One, it could be the individual reviewer. I'll just write individual reviewer. Or expert. Or two, it could be a group of researchers. And a situation where this would occur might be where if you contact someone that has a lab or that has a number of students working under them. So for example, if you think about a research advisor, research advisors, especially at larger institutions, can have, well, when I was doing my PhD, I was part of a group of 8 different grad students all working on a PhD at the same time. So our advisor would get invited to review a paper and he didn't necessarily want to do it, so he would send it to one of us to do. So you could have here a collection of area experts where one expert is elected to write the review. Okay, and then elected, of course, would be a very diplomatic way of saying told to do it, depending on the context. Okay, so the sampling frame, which is the last part. We can break this down into different components based off of what we saw above. So of course, the sampled population here okay, so this would be reviewers that submit a useful response. Okay. And then we might have, for example, not eligible for survey. So this could be, for example, an area expert that has retired from the field So someone that has retired. So we might not consider that person relevant if they might have been an expert maybe 5 to 10 years ago and are well known in the area, but they have retired and have stopped actively doing research, so they might have been they have become outdated in that sense, or they have unfortunately passed. Okay, so this actually does happen a fair amount. A lot of the time, for example, you might have a list of researchers that have made significant contributions, but you don't know personally, and you don't stay up to date necessarily on what they have been doing over the last few years. So in some cases, they do pass on, and you're just not aware that this has happened. So you're sending emails to an address that you have, and you're not getting responses. But that could be one of the reasons why you're not getting a response. All right. So not eligible for the survey would be someone that is considered an expert, but obviously is incapable of providing a response or is not necessarily still up to date with the field. Okay, so then we could have the not reachable portion. Okay, so an example of this might be an expert that has changed institution and therefore has a new email address. Okay. Then we could have refuse to respond. This, of course, is fairly self-explanatory. They are basically telling you to get lost. I suppose that's a little bit unfair. Maybe they're just too busy. Submit a review. And then we have not capable of responding. Okay. So this one, you can see here, this is going to have a bit of overlap with the not eligible for survey. I mean, some of these things might, kind of, overlap with each other in the sense that someone not eligible might also be someone that isn't capable, but it could be, just to try and differentiate them a little bit, this could be, for example, a non-retired expert that changed areas in the last 5 years. Okay. So based off of the description, where we were interested in selecting reviewers to work on a particular piece of work to determine if it's eligible for publication, this is one of the ways that we could break down those key definitions that we discussed on the previous slide. So we have the element, the target population, and then we have a discussion of the sampling unit, and then we have a breakdown of what the frame could look like in this particular illustration. And this type of example is similar to what you're being asked to do on the first question on assignment 1, which I posted last night. So in that question, the goal is to break down an article that was released by CTV News Calgary. Yeah, CTV News Calgary on January 5th. And in that article, they, the statements very clearly define a target population. The statements very clearly give you an idea of what they're trying to estimate. And then they comment on the structure of the sample. Now, we can't really necessarily break the frame down. Well, actually, you can using the second link I sent you, which was to the website that actually tells you where the sample came from. And from that, you can get an idea of what the frame is, how the frame was constructed. So the idea of that first question is to try to get you to essentially critically analyze this piece of work to determine the different components of the sampling frame, identify the target population, identify the sample, and then look for things that could be misleading in how the results are discussed based off of what the actual report details compared to what the article details. Okay, so this is an illustration of kind of what we're looking for in that first question. Does anyone have any questions at this point about this work or what I've written? Actually, this work / what I've written, because they're the same thing. All right. I'm not seeing any, but I'm going to assume that everyone is still alive out there. Okay, second illustration. Now this is slightly different from the first illustration in that we're not going to break down the frame into its components and that kind of thing, but we're just going to talk a little bit about how the frame or the sample is built based off of a formal evaluation from StatsCan. So we have here, one Canadian labor force survey estimates unemployment rates across Canada on a month-to-month basis. So there's this continual survey that gives us unemployment rates across the country, which would be a statistic or a parameter if it's based off census information that we would be very interested in, or that the political parties that are running the country would be interested in, you'd think. So for details, you can search for the labor force survey on Stats Canada's website, statcan.gc.ca. And actually, it's worth pointing out that if you are interested in sampling, so at the end of this course, or even as we move through the course, you start to kind of realize like, oh, I like this kind of work. StatCan does a lot of different survey studies, and I've seen presentations at conferences in the past from people that work at Stats Canada where they're really working on kind of cutting edge survey analysis. So they're looking for new ways to refine and construct surveys to really give Canadians a sense of what is going on in the country from an analytical point of view. So, and they do, from what I understand, tend to hire undergraduates. So persons that have graduated with a stats degree from or finished their undergrad in statistics, and it's a kind of a rolling sort of application process. So if you're interested in this kind of stuff, that would be a great resource to look into. And statcan.gc.ca is a fairly easy site to navigate, so you can certainly look into potential hiring opportunities there. And as I said, they do some very interesting stuff, and they're really focused on collecting information about Canadians for Canadians. So it's a cool place to work if you are looking to get into the workforce and maybe not continue on into grad studies and that sort of thing. Okay, so let's talk a little bit about the sampling frame for this particular problem, just to give us an idea of their approach to collecting information about unemployment. So StatCan's approach to collecting information on unemployment. Okay, so first off, the sampling protocol does not choose sampling units. Okay. I don't need a comma here. Instead, it chooses households. Okay. And the variable of interest are then measured on each unit in the, on each eligible unit in the household. All right. So therefore, the household is the sampling unit. Okay. So in this case, the frame, okay, so we have therefore the household as a sampling unit. So then we could say something like, it follows that the sampling frame is a list of households. Okay, now the interesting thing about how the protocol actually works in this particular illustration. For the labor force survey, there are separate frames for each stage of sampling. So the first frame lists geographical areas within large regions of interest. And two, okay, so frame 2 lists households within each geographical area. Okay, and then this idea here, so when you have the changing sampling frame, so you start with kind of, let's say like an entire province for illustrative purposes, and then you break the province down maybe into, regions. So you'd have like, if it was Alberta, you could think of it like, I think they go north, south, central, Edmonton, Calgary zone, right? So you have the 5 zones. And like, let's say that you select 3 zones, and then from the 3 zones, you then select the households. Kind of a crude example, but that's the idea. So you have a 2-stage protocol where you select geographical area, and then you select household from the area. And this would be something like a 2-stage cluster sample, which is a technique that we're going to talk about later in the course. But effectively what this is kind of like a 2-stage simple random sampling protocol where you have changing sampling units at each of the different stages. And then from that, you can construct estimates, and you can construct estimates for the population perimeter of interest. You can bound the estimate, and then you can make statements from an inferential point of view about what's going on. All right, so this is just an idea of how a more formal survey at the government level works in this particular, for this particular parameter of interest, which would be unemployment rate. So you start by selecting area, geographical area, and then you select household from the area. And then from the household, you evaluate the variables of interest on units within, or on elements within the household that are actually eligible to answer. All right. Any questions about that protocol? Seeing none. Okay, so let's look at some motivating examples and talk a little bit about why we need to develop these different sampling strategies. Okay, so first off, one might reference a quote like, "We need data. We depend on data to make intelligent decisions." I mean, I think one of the justifications for studying statistics in the first place is that using data and being able to interpret and analyze raw data can help inform, for example, policy and how you behave during certain time periods, if you will. So we need to understand how to collect reasonable data, and we need to understand how to analyze data. So we have these two kind of um, components of the analytical process. And we spent a lot of time learning about different ways to analyze data, evaluate assumptions. That's been the focus of, our first two statistics courses at MacEwan. And now what we're starting to get to kind of is into, or now what we're starting to do is discuss the preliminary stage where you're actually collecting the data, though we will focus a lot on estimates from that collection as well. Okay, so good data can be used by researchers in almost any area, especially in sort of the modern age with um, evaluating the usefulness of just apps on your phone. I mean, a lot of that just comes down to user statistics. How many times is it getting downloaded? How many times are, what kind of, well, how much time do people spend on it? This kind of thing. It's actually kind of interesting because it's interesting to note that if you look up user statistics, particularly for social media platforms, which was something I was doing when I was writing the first assignment, it's really difficult to find just raw data for how much people are using, for example, Instagram or Facebook or YouTube, which in some sense is surprising because you think you'd be able to find that kind of information anywhere. But on the other hand, it's probably such a massive collection of information. Like if you were to think about every single person that has one of these apps downloaded on their phone or on their computer, and then you were interested in looking at raw data on user time just for each person, like that would be, I think that it would be like it's some insanely high number of people that even just have Instagram downloaded on their phone. I know I read last night, for example, that I think it was as of this month, it was something like or the like button on Instagram is clicked 4.6 billion times a day or something like this. Like it's just crazy how many people use these apps. Anyways, but the point is that trying to find like the raw data is very difficult. And even if you did have it, I don't know where you would store it because the sample size for that would be so incredibly big. Okay, so ideally, we're going to be able to collect information from a representative sample. That's kind of the end goal, or at least, well, that is the goal whenever we perform or we start off an experiment and we want to collect information. We want our sample to be representative, which means we need to properly define the target population, and then we need to sample units from that target population. Now, in doing that, depending on the size of the population, obviously we're going to run into different types of constraints, whether they be time constraints or financial constraints. There's always going to be some hurdles that have to be overcome in order to collect from the pool of people that you actually want to speak to. So in order to get around this, we have to develop effective strategies for collecting information, which again is something I think that Stats Canada works on regularly. All right, now what are some of the things that can go wrong if you don't collect information properly? Okay, well, let's look at a few different examples of that. So this first example comes from this book written by Sheer Height. I probably pronounced the first name wrong, so I apologize to the author, but the book was called Women and Love, A Cultural Revolution in Progress. Now, to be fair, these reports are pretty old. I think that this book was written in like the 80s or something like this. 1990, roughly. So sometime in the 90s, this book came out. All right, so there's a few claims that came out of this book that we can discuss. So one of them was 84% of women are not satisfied emotionally with their relationships. 70% of women married 5 or more years are having relations outside of their marriage. 95% of women report forms of emotional and psychological harassment from men with whom they are in loving relationships. And then 84% of women report forms of condescension from the men they're in relationships with. Okay, so we have these 4 different statistics that came out of the survey. Now, what are some of the issues with this? Because on the face of it, if you were to see an article and you were to just read this, you would go, okay, like this is pretty high. Like these percentages are somewhat terrifying to see, depending on the context that you're looking at it. But one of the things that we always need to ask anytime we see any statistic, whether it be high or low or somewhere in the middle, like the 50% range, is where did it come from? Like, where did the author find these numbers? So in this particular case, there was some criticism about the results. Why was there criticism? Okay, well, first of all, the sample itself was essentially self-selected. Okay, so the respondents decided whether or not they would contribute a response. So the people that were contacted basically said, yeah, I'll take the time to do this, or I'm not interested in doing this. Okay, rather than it being a more representative situation where you are contacted and you have to submit a result, whether you want to or not. The group that was selected to fill out the questionnaire that corresponded to this survey, they were typically members that belonged to all women's groups. Okay. And then the essay itself, or the questionnaire, turned out to be 127 essay questions, right? So this is a really long survey, something that would take likely hours over several days to fill out and complete. So you're getting the people that are responding to this, or the people that are probably, not to be crude, but upset and are maybe in some sense sort of venting through the essay questions when they respond. I'm not saying that's the case in all situations, but it's likely that this might be part of one of the characteristics of the responding population, so of the sample. Okay, so due to the design and the strategy that was used, the response rate was roughly 4.5% of the 100,000 questionnaires that were sent out. So this is a very low response rate. So we have these 4 statistics that I cited on the previous slide. There were probably more results that came out of this particular book. It turns out that this was based off of a very small response rate of a sample that was not, that was likely not representative of the target population, which isn't even very clearly defined in this particular illustration. So one of the main arguments here would be, again, that this is not representative of what the target population likely was. The author argues back, does research that is not based on probability or random sampling give one the right to generalize from the results of the studies, to the population at large? If a study is large enough and the sample broad enough, and if one generalizes carefully, yes. So she answers her own question here. And I agree with her answer. Like, she's saying, if I collect a sample using a probability scheme, it's a representative sample and it's, you know, it's big enough, does this not give one the ability to generalize to the larger population? And it does. Like, this is what we teach, right? You know, if you have your target population defined and you collect information correctly, sure, generalize. I mean, that's the point. As long as you attach the appropriate margins of error to the estimate and you give the reader a sense of the sampling error that's attached to the estimate, there's no problem there. But this isn't a random sample, right? And the response rate is so small, you can't really argue that this is truly representative of the target population. Let's say, for example, the target population is adult women, I think, in the US at the time. So the number of women that responded to the survey in this case was around 4,500. At the time of the survey, approximately at the time of the survey, there were 127,470,000 women in the US. Okay, so let's say of those 127 million, we only surveyed women that were in that were married, so they were in committed relationships, at least in the eye of the law, right? So let's say At that time, about 52% of women were in these committed relationships. That gives us 66,284,400 women that would likely be part of this target population. So our sample accounts for 6.79 times e to the negative 5% of the population. I mean, it's a pretty difficult argument to make that this would be a representative sample. It's an even more difficult argument to make that this would be a random or a representative sample given the scheme that, or the sampling protocol that was used to collect the information, right? So you have these statements that come out about this, the kind of the state of marital relationships, but the problem is that the sample that you're using to make these claims is most likely not representative of the actual population of interest. And this lack of representation leads to misleading results. So we always need to ask, where did the data come from? And is this truly representative of the population that we're interested in? And does the actual size of the sample give us any power in terms of estimation and reasonable outcome, I guess you could say. Okay, so in this illustration, I think that the point that I'm trying to make is fairly clear in that we have to be careful about how the sample is collected, and we need to ask where the information came from. Now, another illustration where things can go awry, if you will, is even in very simple surveys. So for example, let's consider this question asked by the Roper organization. So it's a different example now. We have one question on the survey. It's basically a yes or no question, which I think most of us would argue is not overly time consuming. So probably it's fair to say that the response rate would be very high in this particular case. So the question is written, does it seem possible or does it seem impossible to you that the Nazi extermination of the Jews never happened? Now, what ended up coming out of this particular question was a statistics that said the results indicate that 22% of Americans doubt the Holocaust ever occurred. All right, so this is a very high percentage of people. Well, I think that most of us would consider this to be a high percentage of people saying that this particular event in history, which is very well documented, didn't happen. But what went wrong here? Well, effectively, the question was too confusing, right? So this isn't pointing to lack of representation of the target population. This isn't pointing to a really low response rate. The issue here is simply that what is being asked is difficult to understand. I've read this over a number of times because I've used this example a few times before, and I still find this question confusing when I read it. So the double negative in particular, led people to not follow what was being asked. And the purpose of this illustration is to point out that another key component of our survey or sampling strategies have to be using reasonable questions to collect information. There's no reason to try and confuse or complicate a situation. We should just try and keep things simple and ask directly what it is we are interested in. In this particular case, again, we have a yes or no question. So we don't need to overly complicate the situation. Now, to show that this was an error in question, another organization called the Gallup organization conducted a follow-up poll. And their question was, the term Holocaust usually refers to the killing of millions of Jews in Nazi death camps during World War II. So they define the event. In your opinion, did the Holocaust definitely happen, probably happen, probably not happen, or definitely not happen? This time, only 1% of respondents said it definitely did not happen. Okay, so this is a drastically different result than what we saw on the first page. And the difference again here is really just the clarity of what is being asked. Okay, so in a separate poll, Gallup asked the Roper question again and found that 37% of Americans doubt the Holocaust ever occurred. Okay, so that is, Gallup clarified the question, the response, or the proportion of Americans that thought the Holocaust did not happen dropped to 1% compared to 22% in the previous question. Then they asked that previous question again, and the response, or the probability that people thought it did not happen, went back up to 37%, clearly pointing to an error with the question. Okay, now there's another example that I want to talk about. I'll try and do this a little more briefly since we're almost at the conclusion here. But so in November 2016, the presidential election was held. So this was the original election that featured Trump going up for US president the first time. So this was when he and Hillary Clinton were the representatives for their respective parties, the Republican and the Democrat parties. So leading up to the event, there were two separate projections for the outcome of the election. So you have in these two tables, we have our electoral projections, and then we have our popular vote for the first projection, and then we have the electoral votes for the second projection, and we don't have the popular vote in that case. And then just as a reminder, essentially the way it works is you need to get a certain number of electoral votes in order to be deemed the president. Okay, so you can see that in both of these projections, Hillary Clinton was winning the electoral vote, and she was also winning the popular vote. Now, in the end, she did actually win the popular vote. So that was the correct projection. But the magnitude by which she won the popular vote, so you can see here that we have 48.5 minus 44.9, which would be what, 3.6% difference? She actually won by a much smaller margin. I believe it was closer to maybe like a percent difference in the end. So the projections, at least in terms of the popular vote, were correct in direction, but they were not correct in magnitude. So the actual predicted difference at 3.6%, that was inflated in some sense, or much higher than the actual result. Now, the other issue is, given the structure of how the American political system works, and I think it's similar to how the Canadian system works in some cases, because we also have, the ridings, and you have to win the ridings and the first past the post thing and all that. Given the structure, there is a discrepancy between how the popular vote and the electoral votes actually align. So you can see at least in the first case here, the electoral outcome and the popular outcome, they are matching up, but that doesn't have to be the case. And that wasn't the case in this particular election. So in some sense, using that popular vote to try and influence how the electoral vote is going to turn out is misleading. And again, in this particular election, that very much was the case. The national polls don't maintain the necessary details or scale to make state-by-state predictions. So in that situation, because the poll or those electoral votes are divided within the states, if you can't do the predictions state by state, it makes determining the total number of electoral votes very difficult, because you need to essentially weight by the states, because there's a different number of votes within each of those different states, right? Or the sizes of the electoral colleges are different within each of the states. So the newer approaches utilize smaller state and county level polls, which have been successful, but these approaches still suffer from a lack of availability. So it's hard to contact people, especially in those smaller, more rural states. Another issue was that the development of cell phones has made it very difficult to contact people, right? It's much easier to flush calls with a cell phone. So before the cell phone, it was easier to obtain random samples because of where information was kept. It's more difficult now, so the frame is most likely incomplete in that sense. And now what tends to happen is when you get calls from people asking you for your input on things like the presidential election, for example, you're only going to get responses from the people that actually want to respond. And again, this creates an issue with the sample essentially being self-selected in that case. Okay, and then finally, some of these other things I'm sure you've heard about before, but it's possible that people that were going to vote for Trump didn't want to admit it, so they didn't say what they were going to do. It's also possible that some people decided to vote, or they switched their vote at the last minute, which is, that can happen in almost any situation. And then I think also it's possible that the way in which, you know, President Trump promoted himself, just it resonated with a lot of the country at the time, and it worked as a strategy in that particular setting. So all of these things compounded and combined led to this difference in result. And I'll just wrap that up by saying that effectively what we are trying to do in this case in developing reasonable sampling strategies is very difficult, and trying to find representative samples is very difficult. It's a really hard problem to address. And what we're going to do in this course is talk about sampling strategies based off of probability schemes that should, if properly conducted, lead to representative samples that we can use to make appropriate inferences. Okay, so I'll stop there. On Monday, we'll talk a little bit about the difference between probability and non-probability samples, and then hopefully by Wednesday, we'll get into some more of the mathematical formulations of the probability samples. Okay, so have a good weekend. The first assignment is up and you can start that. And if you have any questions, let me know. Otherwise, I'll talk to you guys on Monday morning. And again, we'll just meet on Zoom on Monday. And then we'll continue with that pattern for the rest of the week. All right, so have a good weekend, and I'll talk to you guys later.